Hey Gillian. So, me and Jency, say hi.
Hi.
We're going to help you with these two problems. So number 7, here's our equations. I just copied them down. And basically what I always try to do is I'll take the first two and I'll go after the last variable. So I always go after the z's here. So I did these first two. In order to get my z's to cancel, I have to multiply the second equation by 3. So I did that down here. I just multiplied everything by 3. So 3 times x is 3x. 3 times 4y is 12y. 3 times negative z is negative 3z. And then 0 is still 0. Then we can add them, and our z's go away. So just combining like terms here, and I got 7x plus 4y equals negative 25. Okay, so that's awesome. Now I'm going to do the same thing with the z's, but instead of the first two, I'm going to go with the first and the third. Same play though. I'm going to multiply equation 3 by 3 as well, and I get this. I get 24x minus 3y minus 3z equals negative 48. Right?
What?
Right. Okay, so combining those, that gives us 28x minus 11y equals negative 73. Okay? Excuse me, buddy. So, here's our two equations. I'm going to switch it up, though. I typically would go after the y here, but look at that. That's going to be a mess. We're going to have to multiply this top one by 11 and the bottom one by 4 or 2. It's still going to be a mess. So I went after the x's here because 7 and 28 are easy. I'm going to multiply the top equation by negative 4. That gives me a negative 28x minus 16y, positive 100. That equals 100. Add them all up. My x's are gone, and I get negative 27y equal to 27. Dividing both sides by negative 27, so watch your signs, that gives us negative 1. Remember, a positive divided by a negative is always a negative. Once we're there, basically I know what y is. I pick one of these two variable equations and we find x. I picked this one right here, but you can pick either one you want. I basically sub in negative 1 for y, solve for x. I get 7x equals negative 21, so divide both sides by 7, x equals negative 3. Then, I know what x and y is, of course. We can jump back to any one of these. I picked equation 2 just because it looked kind of easier, so I went after that one, subbed it in, and basically z comes out to be negative 7 right there. Okay, so that's how you can take that down. Again, I always follow this like first and second, go after the last variable, first and third, go after the last variable, but shift gears if, it gets kind of crazy. Now, question 9, very much the same play, but it's tougher because we have to do a little bit of modeling. So if I just read the question to you, the first sentence we get is the sum of 3 numbers is 11. Well, there's our 3 numbers, x plus y plus z. Just call them variables so we can talk about them. Adding them all up equals 11. Then we have some more information. The sum of twice the first number, so 2x plus 3 times the second number. That tells me, oh, excuse me, bud. That tells me that we're adding the sum of twice the first number and 3 times the second number. So 2x plus 3y. And that... Just give me 1 sec, buddy. Okay? So that gives us 3y. And 4 times the third number equals 40. There's our second equation. And then our last piece of information, the difference between 4 times the first number and the second number is 2. Now there's no z here. That's okay. I just leave a spot right there so I can keep everything fine. We can still totally solve this. Just go through. And basically here, it's even easier because once you go after your z's, like multiply that top one by negative 4, go after your z's, then you have two variable equations anyway. So that will help you a little bit more. Okay? Hope that helps. If not, let me know. Say bye.
Hi.